Hi, good morning, everyone. I believe we are all in morning, but Belisra is afternoon for you, and whoever may be outside Accra. So, good morning and afternoon to everyone who's here. Today today being our first meetup of the year, we thought it wise to recap the last year, and one of the ways we could do that is by recapping reInvent, which happened last December. And so what I'll be doing today is walking us through some AWS products as well as new products announced at reInvent last year. And so this will be our agenda for today. I'll give a quick intro and then we'll look at compute services, including the announcements in the compute section of AWS. Then we'll move on to storage and databases. Then we'll look at infrastructure, and then a few of the other product announcements that were made. And then questions and announcements and the raffle come from Edwin. So before we start, a brief introduction about myself. My name is Emmanuel Kumsin, and I work with MTN Ghana. I'm a solutions architect, and you can connect with me on LinkedIn, Twitter, and have a small repo on GitHub. I don't code much, but I have a small repo on GitHub, so you can also look at some of the things I spend my time on. And since this is an AWS event, I currently hold 13 AWS certifications and then PMP and TOGAF and also Prince 2 as well. And so that's a brief introduction about myself. Now let's start with today's session. So first of all, let's look at what reInvent is. reInvent is a learning conference organized by AWS for their customers and generally people who are interested in cloud computing. So reInvent usually lasts 1 week and is usually held in Las Vegas. And last year was a bit different because of COVID, they had to go virtual. And so typically in Las Vegas, they have crowds of about 60,000 or more people. I believe last year the numbers were more than that because it was virtual and everyone could attend online. So what is done at reInvent? At reInvent, basically there are product announcements, there are keynote addresses, notably one on infrastructure. This year they added machine learning. There's also the keynotes from the CEO, who is Andy Jassy. And reInvent is for everyone in the tech space. So whether you're an architect, you're a developer, you're a tech leader, reInvent is for you. And there are a lot of sessions for various people. So when you look at the AWS workshops, typically you choose a track, and it's the same with reInvent. When you're a developer, there are some sessions you can attend which are focused on developer services on AWS. Same for the other fields. And so before we go into the product announcements, I thought it wise to bring some business perspective here. So Andy Jassy, the CEO of Amazon Web Services, as part of his keynote, he talked about 8 factors of building a cloud culture of innovation. And I believe that as tech people, we need to understand why we are doing things. We shouldn't just get up to build with the latest tools or the fancy tools, but we should get to understand why we are doing what we are doing. And also, we are all leaders, or we eventually be leading a group of tech people. So when we become leaders, or even in our leadership roles now, I believe we can use some of these tactics to improve our innovation culture. So these 8 points basically touch on technology and then culture. And so the first one is they have the will to invent and reinvent. Invention is bringing out something new, and reinvention is taking something that already exists and making it better. So reinvent is basically about taking things that exist and making it better. Whether it's storage or compute, they've been around for about 30 years, but then AWS continually innovates in this space for their customers. And so that's what reinvention is all about. He made mention of companies like Peloton and Airbnb who took existing services and added technology to it. And now they've changed the way those services work. Point two is you should acknowledge that you can't fight gravity. So if something has to change, it should come from you. It shouldn't come from somebody else, because when another person introduces that, you tend to lose. And so he used companies like Netflix and Amazon to cite his example. When you look at Netflix, they used to rent DVDs. And then suddenly they decided to go into streaming of the same movies they were renting out. So if you look at that strategy, it was basically cannibalizing their DVD rental revenues. But then they stood more to benefit, even though it was a new area, they stood more to benefit from renting, from streaming movies, because that was the internet speeds had increased and people were moving to streaming services and all that. And so they stood a better chance to benefit from streaming. Assuming another company launched a streaming service and then they were still doing their DVD rental business, I'm sure we didn't be hearing about Netflix today. And then with Amazon, they started by stocking books and other products and selling them directly to customers. But at a point in time, they had to make a decision of allowing third parties on their platform. And assuming they didn't do that, they'll be losing a lot of revenues they gain today. Their marketplace is one of their largest revenue streams. So that's culture to cannibalize themselves rather than letting other people cannibalize their revenue is making them still relevant today. Then number three, you should recruit and promote people who are hungry to invent. And so this is more about new people coming into your organizations, people who are willing to do new things, people who are hungry to build new products and services. You notice that most old people or people who have kept long in organizations usually don't bring up anything new after they launch products and services. They only maintain it. Because it's quite difficult to ask somebody to rebuild or make something they've built already. They spend so much time and they are now affiliated to it. To change it to something else is quite difficult. So really new blood promotes transformation and was also encouraging that. 2.4, to solve real customer problems with builders. And so most of the times you find out as tech people like to use fanciful tools, new tools. Today there's Docker, there's Kubernetes, let's use it. They don't think about what the implications mostly are. But then he says that the focus of builders should be about solving problems. If it's in the payment space, your solution should be about solving the payment problem. Your focus shouldn't be mostly on the technology. It's the customer problem first, and then you use the customer problem to inform your choices of technology. Speaking of choices, we move to number 5, where it says speed is a choice. So most organizations have lots of processes that slows them down, and they think that going through all these processes will help them make sure that they are compliant, they don't have any security vulnerabilities and all that. But then he proposes that speed should be a muscle you should flex in your organization anytime it's needed. It should be part of the culture. We all know about the first mover advantage. Anyone who goes to market first with a product is more likely to be the market leader. So for instance, Amazon went to market with the public cloud first, and after 16 years or so, or 14 years, they are still the market leader by and large. And so processes should be tailored in such a way that they don't hinder when you go to market. Number 6, keep it simple at the start of a transformation. So over here, it mentions that when you're using multiple vendors and multiple technologies at the start of a transformation, it becomes complex because there are so many moving parts. But it's best to adapt a partner who can help you start your transformation. As you move along, you look at the other moving parts. Because if you do so many things from the start, it becomes complex and you're more likely to fail. Number 6 ties directly into number 7. Says you should use the platform with the broadest set of tools. So it makes mention, of course, you market AWS because it's an AWS conference. So it makes mention of the fact that AWS has the widest range of services in every section of IT, from compute to storage to analytics to machine learning and what have you. And so when you use such platforms, it's easier to integrate your services. It's easier for one service to talk to the other rather than using a platform with fraction of the features you're looking for, and then you need another one to help you with another set and all that. But it's always best to get it at one place. Number 8, which sums it all, is to compel action with aggressive top-down goals. So in reinvention or innovation, it's always better, or it's most optimal if you are working with top-down goals, because leadership, when decisions are coming from leadership, people are more likely to adhere to it than when it's from a colleague. So he made mention of GE and Capital One. In GE's case, their CIO made a bold goal of migrating 50 existing applications to AWS in 30 days. And people were like, he's crazy and all that. But when they started work, in the first 30 days, they were able to migrate 42 applications. It wasn't 50, but 42 is still a very big number in 30 days. And Capital One is also working on transforming their whole business, moving all the applications to AWS. And these goals were set from the top, and they are succeeding. So now we're done with the business side. Let's move into more interesting tech stuff. We'll start with compute, because that's where everything starts from in the cloud. Any application you run has some form of compute. And so in compute, let's start with the good old EC2. EC2 is Elastic Cloud Compute. It's basically what we know as virtual machines. You can rent them in any form. There are lots of them, and they are usually categorized into families. And the families include the general purpose, compute, memory, storage. There are those for machine learning, and there are other families as well. But today we'll look at just these 4. Those I've highlighted in green are the new instance types that were announced at re:Invent 2020. Those in black already existed. I thought I should put them here to offer a bit of context. And so let's talk about general purpose instances. General purpose instances usually, I mentioned earlier that instances are basically virtual machines, is how AWS decides to call them. And an instance type is basically denotes a compute resource with a certain amount of memory, CPU, and networking, and storage as well. And so general purpose instances, you find out that they have a balance of all these resources I've mentioned, from CPU to memory to disk and networking. They are used to run general applications without any special requirements. And so your typical web applications, even microservices, among others would qualify for these instance families. You run them on these instance families. Speaking of instance types, usually the first letter in the name. So for instance, let's look at M5ZN. The first letter represents the instance family. So when you see an M or a T or an A, it represents general purpose. And when you see a C, it represents compute. When you see an R or an X, it represents memory. D or an I represents storage. Okay, then there's second character, which is usually a number, represents the generation of that particular instance. So the M5ZN belongs to the fifth generation of the M instance family. A1 is still in its first generation. C5 is still in the fifth generation, but there's a sixth generation to the C as well as the M. So that's why I see the C6G under compute. And then usually you have some letters at the end, which could represent the storage or networking or the type of processor. So when you look down, I have the chips they use. And when you see a small g at the end, it basically means they use a graviton processor. When you see a small a, it means they use an AMD. Intel instances don't have any special character denoting that they are using Intel, because most of them use Intel processors. I'll touch based on the processors a bit later. So back to general purpose instances. New announcements included the Mac instance, which is quite exciting because before reInvent 2020, there was no way to run or develop Mac applications in AWS because of the special requirements from Apple. But now, with the new Mac minis running the M1 processors, they've been able to install a lot of Mac instances or Mac minis and virtualize them as Mac instances in AWS. So you can basically rent a Mac mini in AWS by selecting the Mac instance, and then you use it to develop your Apple application. So now you can write your iOS apps, iPad, and all that in Xcode in AWS. Quite exciting times for Apple developers. And it uses the new M1 processor. The M5ZN is also a general purpose instance, and basically it's for applications that need high CPU, so single-threaded applications that need a lot of single-thread CPU or one core. So this gives you about 4.5 gigahertz per CPU. It's quite good for applications that need a lot of CPU on one core. Let's look at the compute instances. As the name goes, they are used for compute workloads or CPU-intensive workloads. So any application you can think of that needs a lot of CPU, especially data analytics, because you need to do a lot of calculations on the data and all that. The C6G, based on the graviton processor, usually gives you a 40% price performance over the usual C5 or the general purpose. There's the compute instance that is not based on graviton. So graviton, since we are talking about graviton now, let's look at graviton. It's a processor developed by AWS, and it's based on the ARM architecture, and so it uses less power and it's also less expensive, but then still gets the job done. So if you are looking to save a lot of money, you can look at the graviton processors. It's now in the second generation. Memory instances are for memory-intensive applications. So you find out that these instances have a lots of RAM as compared to the other types of instances. And a new one that was announced was the R6G. I mentioned G is based on graviton. And there's another one which existed already, R5B, which is optimized for both memory and then storage. Then let's go to storage. So storage, we have the D3 EN, which is new. There's also D3, it's also new. And then the I3 existed already. So the D3 is for sequential inputs and outputs operations. And the D3 is for random IO. So inputs are from anywhere at random and all that. So D3 is optimized for sequential. I3 is for random. That's the main difference when you get to storage. I've already touched based on the processes. So we move on to the next section, which is about ECS. So when it comes to compute, we realized that this year at reInvent, a lot of focus was on serverless and containers. So you realize that apart from these new instance types I've mentioned, all the other sections on compute are either serverless or containers. And that's relatively new to how we used to deploy our applications. That also tells you that a lot of people are moving to this areas. So if you're relatively new to the cloud and you are looking to have some joy there, they should tell you that you should also be focusing on containers and serverless workloads. So speaking of containers, let's look at ECS and EKS anywhere. Before we do that, let me give you a bit of background to why there's ECS and EKS anywhere. So ECS stands for Elastic Container Service. It's a managed container orchestration service from AWS. By this, I mean it's a managed Docker service. If you know Docker, Docker is used for building images for containers, distributing them, and even for some form of orchestration. Orchestration is basically getting your containers to run on in a cluster on different nodes spread across different data centers or in the same data centers, how you manage their deployments, how you check their health, how you update them, among others. And so ECS basically comes in two forms. There's the provisioned and there's the serverless. The serverless you don't worry about. Anytime you hear serverless, it means you don't worry about what resources you are going to use. Most of the times you set some form of range because you don't know what exactly you need. So you set some form of range and then AWS manages that for you. Provision, you say categorically that I want this instance type. And when you choose an instance type, it means it comes with a certain memory, a certain count of CPU, and some network bandwidth. And ECS, why would people use ECS when there's Docker? Simply because ECS natively integrates with a lot of AWS services. So there's App Mesh for observability, there's CloudWatch, you can use it with S3, among a whole lot of other AWS services. So it makes it easier. And this ties into Andy's point on choosing a platform with the broadest set of tools. It makes integration easier. When you're using Docker, you have to worry about plugins for various things. But then over here, it's already done for you. You don't need to worry about these things. Now to EKS, which is the managed Kubernetes service from AWS. It's just like the ECS, but now the focus is on Kubernetes, which is purely based on container orchestration. So you can run your applications, you can scale them, and because of how cloud is architected, it comes natively with high availability and security. You don't have to worry about this. It's already there. I mean, you run your workloads in multiple availability zones and use security groups. There are knuckles, there's IAM for access and all that. So these are already baked into the service for you. Don't need to worry so much. All you need to do is administer them. And you also don't need to worry about upgrades, provisioning new nodes, patches, and all that. And the interesting thing about EKS is you can even run it in your data center. So as part of your cluster, you can choose nodes in your data center. Now let's move, now that I've built some context into this, let's and move on to ECS and EKS anywhere. I read somewhere that a lot more containers are being deployed on AWS now than EC2 instances are launched. So that tells you that containers, even though they are new, relatively new, they are popular, and a lot more people are yet to start using them, meaning that this would grow, these numbers will grow. And so AWS, as part of supporting customers, decided to make these services, ECS and EKS, available to their customers wherever they are. Google and Microsoft already run similar services for their container, managed container services. So EKS and ECS Anywhere are basically installable software packages. You can run them in your data center. They give you the same field or the same features as ECS and EKS will give you in AWS. You can run them on Outposts. I'll talk about Outposts later. It's infrastructure agnostic. It can be run on any infrastructure, whether it's Windows or Linux. And the good thing is you can use Systems Manager. If you are familiar with AWS, you realize that Systems Manager helps you manage your virtual machines, whether they're already in AWS or they are your on-prem. You can use them to upgrade your software, among a whole lot of other things. And one of the reasons why we should consider using ECS and EKS anywhere if you're in the container space is you don't need to worry about how your deployments will work on other infrastructure. So typically, if you are running Kubernetes or Docker, the open source versions, you need to worry about your storage drivers. You need to worry about networking. Even though there are lots of solutions, you still need to make a choice there. But then EKS and ECS Anywhere already have these things baked into, and they make your environment look like AWS already. So you don't have to spend time planning all these things or looking out for these solutions. It's relatively convenient. Now, this is a high-level architecture diagram of how ECS Anywhere will look like when it's deployed. Mine is not available yet. It will come later in the year. So the top section shows us the AWS parts of the cluster. And then you can extend it to other AWS edge services like Wavelength and local zones or outposts, or even your own service or in your own data center. I won't speak much about Wavelength and local zones here. I have a slide on that later. So we can move on to Lambda. This is one of the popular services in AWS. There was one announcement made there, but I thought I'd give a bit of context to what Lambda does, and then we'll come to the new announcement. So Lambda is a serverless complete serverless service, sorry. So serverless basically means that you don't worry about the underlying infrastructure. It doesn't mean it doesn't use servers, it uses servers, but you don't provision those servers. Someone manages that for you. All you have to do is bring your code and run it. You don't care about where it runs, but it runs. It supports most of the popular programming languages. It supports Java, there's Go, there's Node.js, even supports Docker. So you can build anything in Docker and then just put it there, it will run. And so how serverless works is something needs to happen for your code to be run. In other words, triggered. So for instance, by me saying something needs to run, an event needs to occur. So for instance, your server, when your server stops, that's an event. When someone uploads data into an S3 bucket, that's an event. So all these events from different services can be used to trigger your applications to run. That's how it works. And right it works with over 140 AWS services. That's virtually all the services in AWS. Then the announcements made at reInvent. Lambda used to be built based on the time used to run the application. So before, when you run an application, Lambda will bill you based on 100 ms. So if your application runs on, the billing unit was 100 ms. So maybe if your application runs for 200 milliseconds, you pay 2 times the unit price. So maybe the unit price is $0.0001. If it runs for 200 milliseconds, that's 2 times that. But now they've upgraded the billing where you are charged on 1 millisecond basis. This means that if applications run less than 100 ms, you are going to save lots of money. As I'm saying, lots of money is typically you run so many functions over a time period. So I said functions. Lambda can also be referred to as functions. Serverless can also be referred to as functions. So bear with me there. Yes. So if your workloads run in less than 100 ms, then you get to save more with this new upgrade. So that's the latest announcement in the Lambda space. Now let's go to another new service which is available now. You can start using it. I talked about ECS and EKS, which were focused on containers. Now there's a new service, AWS Proton, which is also focused on containers and serverless. What Proton does is basically gives you a console you can use to manage all your container and serverless workloads. It employs the infrastructure as code. And infrastructure as code is basically you writing code to provision your infrastructure. So you don't go to the console to click, I want EC2 with 8 gig of EBS storage and this security group and that security group. You don't select that. You write all that as code and then upload it, and it's deployed for you. What this does is that you can readily reuse these templates anytime you want to build, especially when you are in a dev environment, even production, because you have a snapshot of what your production environment is like. Anytime you want to upgrade, you just go back to the template and version, create a new version and pass it through your CI/CD. I believe this year we'll be doing a lot on these things. So if it doesn't make sense now, just bear with us. I'm sure most of our meetup this year will be touching on a lot of CI/CD and infrastructure as code stuff. But then it organizes your workloads. Before, it was quite a messy playground. You have resources in Lambda, you have deployments in Lambda, you have deployments in ECS, you may have done your own deployments on EC2 and all that. But now this gives you a streamlined view of all these deployments, and you can always go back to them and check your logs and other metrics and all that. And so your deployments are now shown to you as stacks. If you use CloudFormation, you know that a stack is an instance of a template. The templates I referred to earlier. So that's your template is deployed, and that becomes a stack. It ensures that best practices are enforced. And one other benefit is that developers now don't need to worry about how to deploy these applications. A lot of people are moving into this container and serverless space. So it helps developers to just focus on their code whilst AWS manages the deployment stuff for them. And by so doing, they adapt new technologies like infrastructure as code. Now let's move on from compute. We've talked a lot about compute. That's where everything starts from. Let's go to storage. Storage AWS has EBS. I think there are about 3 storage services in AWS: EBS, S3, and then EFS, which is the network file system. EFS is Elastic File System. Okay, but today we'll touch on EBS and S3. So in the EBS space, EBS basically gives you block storage. Block storage is storage that is not necessarily attached to your compute or your virtual machine, but then you can always write or read from them over a network. Okay, and it's used for, there are various kinds of EBS volumes, and this allows us to use them for various applications. So based on your application, you select the type of EBS volumes to use. There are 2 main types of EBS volumes. There's the HDD, which is hard disks, as we know, and then there's the SSD, which is solid state, and it's relatively new. So hard disks uses magnetism to write to your volume or your storage, and SSD basically uses integrated circuits. So one of the advantages of SSDs is that because it uses circuitry can always be shrinked, and so you can use it in smaller devices, as well as not necessarily need a very big device to be able to write a lot of data onto. Once you're able to shrink the circuitry, you can add more storage. And so that's one of the advantages, but it's relatively expensive than hard disks. And so in this slide, I'm only going to talk about SSD-based volumes. I won't touch on HDD. So when it comes to storage, there are 2 main metrics, or 2 things to look at. You have the IOPS, and then you have throughput. So IOPS basically refers to the number of read and write. Input is write, and then read is output. Yes. So a number IOPS refers to the number of reads and writes per second on a storage device. And then throughput is the number of bits. So the data itself you are copying onto the disks. Yeah. So that's the distinction. So these are the 2 metrics used when you are looking out for a storage device. Now, depending on your application, you may need a lot of IOPS, or you may need a lot of throughputs. Hence the different types we have here. So with the SSD, we have 2 main types of SSD: the IO and then the GP. IO refers to inputs, outputs. You can also refer to it as the provisioned IOPS. And you have the general purpose, which is GP2 and GP3. So general purpose, the difference between general purpose and IOPS is that with general purpose, you are given a number of IOPS based on the volume you select. But with provisioned IOPS, as the name goes, you can set your IOPS to be different from the size of the volume. So for instance, when it comes to provisioned IOPS, that's the first 3. If I buy maybe 1 TB of storage, or I select 1 TB of storage, I can decide to use the maximum IOPS there is. But whereas with GP2, if I select 1 TB, it will give me a IOPS that is proportional to 1 TB. So each of these types had a new updates announced that reinvents. When it comes to IO, they introduced the IO2 Block Express, which is an upgrade upon the first 2, IO1 and IO2. So IO2 Block Express gives us a maximum of 256,000 IOPS per volume, whereas IO2 was giving us about 64,000 IOPS. And so that's, you see, that's about 4 times higher IOPS than the previous generation. And then when you go to the general purpose, there's GP3 now. And GP3 basically gives us a baseline performance of 3,000 IOPS and 125 megabits per second at any volume size. This means that at least the minimum you get is 3,000 IOPS per any volume size. Before, GP2 used to give you lower. And one advantage of GP3 is that even with all this performance, it's still 20% cheaper than GP2. So this is in relation to storage. Now let's move on to S3. S3, we talked about block storage earlier. Now let's talk about object storage. So with object storage, it's a bit different from block storage, because in object storage, your files are put in sort of a virtual folder, and they are referred to as objects. So your folders and your files are all objects. You can't say that your data is at this part of the disk or that part stored in a virtual environment. And one good thing about object storage is that as part of its design, it gives you some form of redundancy. But that's not what we are here to talk about today. Today, we are going to look at the announcement, the new updates in this space. And one of the features of S3 is that it gives you a tiered storage. By tiered, it means that there are levels to the performance or the KPIs AWS is giving to you for your storage. You can use them for data lakes. You can use them to back up your files. You can use them to host your websites. Even though it's storage, you can use it to natively host your websites. So now to the new announcements. There's strong read after write consistency now. Before it used to be first byte consistency. What this new update means is that once you write to S3, any replica of your data you read is going to have the updates. Before, it stores it on one of the replicas, and that is readily available to you. But if you check from other replicas, you may get the old data. It takes time to cascade those updates to the other replicas. But now, for get, put, list, and other operations, really write anywhere you read the data, you're going to get the same information you wrote, irrespective of the time you check. Now there's multi-destination S3 replication. So S3 replication is, before I explain replication, maybe I should talk about buckets. So when you are using S3, your data is stored in a bucket. It's a virtual container, which you can put any type of file there. And so if you want to access your file, you need to access the bucket and then to a specific directory in the bucket to access it. Now, buckets are based in regions. And so I'll be talking about regions later. What this necessarily means that your bucket is located at one place and maybe backed up in the same place multiple times. Now, assuming that place is Johannesburg, what happens if the Johannesburg data centers are all out or there's no internet to Johannesburg? You lose that data. So as part of disaster recovery, you find out that people will be storing their data in Johannesburg, but then they also want to back up the same data elsewhere, maybe in London. And so what happens is that because you don't want to do this manually, you can use replication so that when you upload data to Johannesburg, the bucket in Johannesburg, it automatically copies the same data to London, so that in times when there are disasters or you can't access Johannesburg, you can bring your application back online with the copy of the data you have in London. So that's replication. Now, it used to be only one replica replication, but now they support multiple destinations. So for instance, at first you could only add London or maybe Ireland, but now you can add London and Ireland at the same time. You can add Germany, you can add US at the same time, and your data will be replicated to all these places. It's still with replication. Before, replication was one way, so it could only be Johannesburg to London, but now they support the bi-directional. So when data is also uploaded to London, you can set up a rule to also replicate that data in Johannesburg. By so doing, both buckets will be up to date with all your data, irrespective of where it was first uploaded. Then now there's also an update to the bucket keys. Now you can use a single PMS key to encrypt and decrypt all your objects in the bucket. Initially, you need to specify the PMS key to use for every object. Now it saves time and also saves money because you can use just one key and then use that for all your encryption and decryption needs. Let's quickly move on to database. So in the database space, all the announcements were related to Aurora, which is part of Amazon's relational database service. Now, Aurora basically gives us managed database, and this managed database is based on MySQL or Postgres. The difference or the main benefits with Aurora is that it's faster. So MySQL is about 5 times faster as compared to the open source one we know. And Postgres is about 3 times faster than the Postgres open source we know. Also, because Aurora is from AWS, it's purpose built for cloud. And so this means that they factor in the architecture in the cloud, like high availability, fault tolerance, security, all that is already factored in. So if you are running workloads in the cloud, it serves you best if you are using Aurora as compared to the MySQL you know, or the Postgres you know. Aurora is distributed, it's fault tolerant, it has a self-healing storage system. That's one of the innovations in that space. Once there's a fault with your data, it automatically detects and then adds a new node to your storage. You can scale that up to 128 terabytes per database instance. And of course, because it's built by AWS, it's natively integrated with a lot of AWS services. So that's Aurora as we know. But then there's a serverless version. I mentioned that when it comes to serverless, you don't worry about the resources you are using. You can, when it comes to Aurora, you can set a range. Capacity is defined in Aurora capacity units. So it's some form of virtual CPUs and memory. And so in version 1, now there's version 2. In version 1, you could increase or your capacity scales by doubling the current capacity you are using. So assuming Aurora detects that you need more capacity, it just doubles the number of capacity units you are using now. So if you're using 10, it doubles it to 20. But then Aurora version 2 increases it on, I think, 0.5 capacity units basis. So this saves you money because you're going to use just what you need. In addition to that, of course, it has all the features Aurora provisioned already has. It's multi-AZ. You can use global database. You can use the proxy. the added advantage with Aurora serverless version 2 is that scale down can happen in a minute. With version 1, it used to be about 15 minutes or so. So all this helps you save money. So you could see that in the past year, I have a feeling AWS is really listening to customers, and a lot of the new products they've introduced, even though they are innovative and all that, they also have a cost savings element to it. So I think they are doing well. They should continue in that light. And then another announcement for Aurora is Bubble Fish for Aurora Postgres. It's now in preview. So you realize that most commercial applications on the market these days, when you're buying an ERP or a CRM, usually comes tied with a database. So it could be Postgres, it could be Oracle, it could be Microsoft SQL Server. And so usually when people are moving those applications to AWS, after worrying about how to move the application, you also have to worry about the database and all that. But in the previous slide, I spoke about all the performance benefits of Aurora and the innovation in that space. So usually, because they are all SQL-based databases, but then SQL has different dialects. So what Oracle uses is different from what Postgres uses. It's also different from what Microsoft SQL Server uses. So typically an application written for Microsoft SQL Server will have errors if you change the database to maybe Postgres. But then Amazon has been working in that space, and now they've introduced a translation layer. So if you have an application running in Microsoft SQL Server, this Bubble Fish, which is natively integrated into Postgres now, would handle the translation of the SQL dialect to the Postgres running in Aurora. So you don't need to write any application or use any third-party tools, or you don't even need to by force use SQL Server in AWS for that particular application. So now this saves time, because when it comes to migrating your database, you can use AWS Database Migration Service, and then you can also use schema conversion tool if you are changing to another database. That would work on changing the schema to meet the other database requirements. So what this does basically is saves you time, and the work you have to do in cutting over your application reduce drastically. And I mentioned earlier that it's already natively part of Postgres. It's in preview, so if you're using the normal Postgres, you will not see it now. So it becomes generally available. Having said that, let's move to infrastructure and other announcements. So I made mention earlier that I'll be talking about infrastructure. The top three have been with us for a while, and then the bottom three are relatively new. So regions, availability zones, edge locations. I mean, when you start using the cloud, you'll soon find them out. So regions basically refer to a geographic area with multiple data centers. So they are isolated and separate, but they are connected together logically or via networking to serve as one geographic center. What this does is that you can deploy application in a region, and then for high availability, you use the other data centers in the other parts of that region. So that's how high availability is achieved in AWS. And the reason why there are regions is that most countries have laws that prevents data from being stored elsewhere. So for instance, if you are in Africa and the law in your country says that the data cannot leave the continent, then you can use the South Africa AWS region, because that's what the law says. And if you're in the EU, you can use any of the regions in EU. There are a number of them. You don't have to necessarily use the US data centers. So that's how regions work. I touched a bit on availability zones when I was talking about regions. Availability zones are discrete data centers. So it could be one or multiple in the same location. They have redundant power, networking, and connectivity. So they have different ways of connecting to the other data centers in the region. So all availability zones, which are data centers, are connected to each other in a particular region. So I mentioned earlier that it's used to achieve high availability. When one data center goes down in the region, if your application is highly available, it should still be able to work because you have it deployed in other availability zones in that region. Edge locations are small data centers, and these are typically used by CloudFront, which is a caching service introduced by AWS. So it's a CDN. It's used to cache static and dynamic content. It works closely with Route 53, which is a DNS service, and then S3, which is an object storage service. And so typically, I mentioned when you deploy websites with S3, you use CloudFront to cache it globally. There are about 210 or over 210 edge locations, and there are 12 regional caches from AWS. Now to the new infrastructure services, or relatively new infrastructure services from AWS. You have the local zones, you have Outpost, and you have Wavelength. So there are now 5. Most of them are yet to be deployed. They were announced, but have not been deployed fully yet. So you can find a local zone in Los Angeles, I believe. So local zone is not an availability zone or an edge location. It's just AWS infrastructure that's deployed closer to a large population or where there are lots of industries or IT companies. The idea is that you get AWS, because these people use a lot of AWS, you get AWS closer to them. And so you can term this as an edge service because it gets AWS resources closer to them, even though it's still the AWS cloud they are accessing is quite closer to them. As compared to me being in Accra and then I'm always deploying applications in Virginia in the US, that's a lot of latency. But if we had a local zone in Accra, it would be as if I'm directly in the data center, or networking would be pretty fast as compared to connecting to a region that is far away. Then Outpost gives you AWS in a rack. So you're basically enjoying all the AWS services, or most of the AWS services in your own data center. So before they give you a full rack, and you can run RDS and EC2 and a number of AWS services on it. And now the latest, sorry, my slide moved. Now the latest addition is that they can give you a 1U or a 2U server you install in your rack, and then you can use that to run AWS services. So these are shipped by AWS to you. You don't buy them from anywhere, or you don't install your own service. The 1U and 2U racks, what this would help do is, assuming you're a business and you have branches elsewhere, you could use these small units in the branches to deliver services deployed in AWS for your employees. Or if you have a remote site with limited space and power and all that, you can deploy these small units there. And then to Wavelength, which is also a bit new, this tied to 5G. What this does is AWS infrastructure is deployed in a service provider's 5G network so that they can deploy 5G applications. 5G applications need data and they need low latency. So by deploying the AWS infrastructure in the edge network of the service provider or the telecom provider, they're able to deliver low latency applications to them. So typically these self-driving cars and flying drones and what have you benefits a lot from this. Quite recently, I heard someone is building a VR solution for sports using wavelength. So it's relatively new and it's open to a lot of innovation. Having talked about infrastructure, let's look at the new services announced during other services announced during re-events. This don't fall under the other sections I mentioned earlier. So I group them under other announcements. The first is Trainium, which is basically a custom chip. So speaking of custom chips, we talked about Graviton earlier. AWS has another chip for machine learning. And this is currently used in Trainium and Inferentia, I believe. And so Trainium and Inferentia work in the same space. Trainium is for training machine learning and deep learning models. And then Inferentia is for making inferences or predictions from those trained models. So before there was Inferentia, and then this year they've introduced Trainium. The whole idea is that these chips are optimized for this specific task and they are relatively cheaper as compared to the general purpose chips people were using earlier to perform the same activities. So those of you who build machine learning applications and train models, Trainium is for you. And there's Lookout, which is also a machine learning service. It comes in three forms. There's the Lookout for metrics, there's the equipment, and then the Lookout visuals. They all do the same thing. They detect anomalies. So the metrics detects anomalies in metrics. The equipment detects anomalies in how equipments function. So for instance, a conveyor belt is trained to see the normal behavior and then also abnormal behavior. So if anything goes contrary from the normal behavior, Lookout for equipment will detect that and notify you. So this for manufacturing and the wider industries. Visuals works at the same as equipment, but this is general visuals, not just equipment. So maybe you deploy a machine learning, you have a camera at your house that uses visuals and Lookout visuals. And when the normal behavior is that nobody will be in your backyard. So when an intruder enters there, that's abnormal. And so that would notify you that there's an anomaly detected. So that's how it works. It basically detects anomalies. Then there's the Amazon managed service for Grafana and Amazon managed service for Prometheus. So those from the observability or DevOps fields, you know, Grafana and Prometheus. Prometheus are for gathering, metrics, and Grafana is for visualizing the metrics. These are open source tools. Now Amazon is bringing a managed version to the cloud. So if you are familiar with this product, you can go ahead and be using them in addition to your CloudWatch. Yeah, and you don't have to worry about deploying them because it's AWS handles all that, the upgrades and what have you. Now to the last announcement, there's Cloud Shell, which is basically a browser-based shell that you can use to access your AWS resources. Before we used to have the CLI, and then you could use the SDKs and APIs. So Cloud Shell is just the same thing, but now you can access this in the browser. So if you're familiar with the CLI, the Cloud Shell shouldn't be so new to you because it's just deployed in the browser now. And so that brings me to the end of my presentation. I'll pause here for any questions or any comments on this recap we have done. Then after the questions, I hand over to Edwin. So the floor is opened. Anyone who wants to.
All right, Emmanuel, so thank you very much. There's one question pending from Daniel. If you can pick up from the chat.
Okay.
Yeah.
So the first question is, I'm going to read as I see it here. Okay, I think Beliswa gave a link for what she posted, so I'm not going to touch on that since there's a link that can refer you to that. So there's a question from Daniel here. Could you please highlight again the difference between bubblefish, DMS, and SCT? That's a good question. So let's start from the basis. There is the database migration service, which is termed as DMS. If I have a Postgres server running in my data center and I want to migrate it to AWS using RDS or even my own EC2 instance running Postgres, I'm going to use the database migration service. It basically copies my Postgres on-prem and takes it to AWS. That's what it does. Now, if I'm moving from Postgres on-prem to, let's say, SQL Server, Microsoft SQL Server in the cloud, I'm still going to use DMS, but I need another tool to translate the schema because the Postgres schema is different from the SQL Server schema. So the schema conversion tool basically maps the schema to different columns in the new database. That's the work of schema conversion tool. It works hand in hand with DMS when you are migrating to a different database. So that should complete your database migration. These two tools should complete your database migration too. But then there's another headache from developers. Assuming I buy, what's a popular application out there? Assuming I buy, why is no application coming to mind? Assuming I buy an ERP from any vendor, and that ERP works with the Microsoft SQL Server database. The ERP came with Microsoft SQL Server. If I move it to the cloud, I need to use Microsoft SQL Server. Assuming I'm able to migrate the application to the cloud using any of the migration services available today. If I move the application to the cloud, I have to use SQL Server. What happens if I want to change from SQL Server? Because now the licensing is outrageous if I'm using AWS. There's no easy way you do that because SQL Server uses a different dialect from the other databases, for instance, Postgres. And so your application will have errors because the application was written to read and write from and to SQL Server. And so Bubblefish for Aurora is just a translation layer, which will translate the application's SQL syntax or whatever to Postgres. Thereby, you can use it. It's not straightforward like that. There's still a bit of work you have to do, but that's the intention, that it translates the SQL dialogues to what Postgres can understand. So it's just a layer in between that will change the language the application is speaking to one Postgres to understand, because the application was written to talk directly to SQL Server. So that's what Bubblefish does. Right now, it's only SQL Server, but I believe they'll be adding Oracle and other commercial database. I believe that's the intention. But now it's only SQL Server. And I'm sure as time goes on, they may introduce the same for MySQL. Now it's just Postgres. So Daniel, is it clear now? Have I answered your question?
Yeah, so Daniel says it's clear. It's written from
okay.
All right, so Emmanuel, thank you very much for that explanation. I think we are we are still in our official time, but I think we are pretty much close with time. So I'm not getting any more questions from the chat, so I think we will move on. So at this point, I'll invite Veliswa, senior advocate, developer advocate at AWS, to share a few words with us. Then we will take some announcements and then have our raffle.
Thanks, Edwin. Thanks, Emmanuel, for that presentation. It was really good. Hi, everyone. So like Edwin already said, I'm Veli Swaboya. I work at AWS. I'm a senior developer advocate. I recently joined, so I'm sure all of you have met Guavas Bernard before. So I'm taking over from him. He's moving on to another team, still staying with AWS, but moving on to another team. So my thing, I'm looking to connect with as many of you from Sub-Saharan Africa, and just so that we get to meet and then we share. I've actually created, I'm going to paste it here on the chat. I've created this group on LinkedIn. Here we're hoping to share AWS news that matter to us in Africa. That's the idea of that group. So if you're on LinkedIn, if you can just follow that link and join it, and then we'll be sharing stuff there that actually matters. As I find out more things that pertain to us, I'll be sharing there, and you can connect to me as well on LinkedIn, and then we can just be connected. Thanks for the platform, and thanks for today, the presentations.
All right, Veliswa. So thank you very much. So we would, a few announcements. So this year, we really want to do very well and be more active than ever. So this is the first of our events this year. In February, we would have at least 2 events. Most of those events will delve on deployments. So we will do a bit of serverless deployments with cloud formation, that's deploying with templates, and then a bit of understanding what pipelines are and their role to play in all these different kinds of deployments. So I think those will be very interesting sessions, and I know it's something that a lot of people really like to have some knowledge on. And really, it's not it's not a big deal to know. You just need to understand the fundamentals and the basics of it, and I think you should be pretty much fine. So I'll be looking forward to more engagements within the year, then also the next month and the coming months. Let's look out for a lot more activity from the community this time around. All right, so let's jump into our raffle. Emmanuel, let me take over the screen. So all right, so yeah, we had to quickly bake some application for our raffle. So pardon me, it might not be it's, let me say, it's in beta now. So but the functionality should actually work. Yeah. So we have all the participants for today who might win credits. So we have ourselves here. I believe I'm not missing anyone. So we have George. All right, so we'll go ahead, take a spin, and we'll see who our winners are. So we'll take 2 spins because we will be giving out two $25 AWS credits for your own personal development. All right. All right, so our first user winner is Zoom user. Zoom user, I'll be grateful if you can share your email right now in the chat because your name is a bit generic. I'll be grateful to have your email shared in the chat now. so that we know we can send you the details. So let me do the next spin. Let me reset. All right. So yeah, like I said, our application is still in beta. So yeah, there's some parts of the algorithm we would like to look at. So I mean, one person can win twice, so we would redo the spin. All right. So I think Zoom user is Fifi Bedu. All right.
Yeah.
So Fifi, yeah, I've gotten your info. So let me do the spin again. All right, good. So we have
Yeah.
another winner. That's Daniel. So at least I know Daniel personally. But Daniel, do share your email as well. At least I don't have your personal email. So share your personal email. So we will send the 225 AWS credits to each of you. And like we promised, for all our events, we will do well to share, to give away, to have a number of giveaways, mostly the credits, and then whatever else is available at the time. Now, we still do have some stickers, AWS stickers, and other souvenirs, mainly the stickers. So, unfortunately, because of COVID, we are not having in-person meetings or events now. But needs, um, whoever really needs some stickers, please do well to engage, and yeah, that should be good. All right, so in fact, yeah, very useful. So in fact, I have volunteers who made this happen. I need to give them some credit. So Vincent Kwenu volunteered to build the backend for this. This backend is currently running on Lambda and API gateway. I think when we begin to go into some of the deployment and stuff, these are applications which will actually go back and look at what the architectures are. So yes, Vincent, I already have some credits to give him. So he'll definitely, if he had won this, it will be double for him. But yeah, I'm definitely going to give Vincent some credits outside here because he's volunteered to build the backend for this. I also want to give credit to Akwesi Cyprian. I think he's here as ever trendy. So Akwesi basically put together the front end for this. And yeah, guys, you've done well so far. We will polish it up a bit more for future events. So thank you all very much. And please have a good day, and we would continue to do a lot more this year. We will do well to share the video or the playback for our event on YouTube as usual, and the other platforms we are on. So thank you all, and have a good day.
Thanks. Bye bye.
Bye.
Bye bye, everyone. Thanks for attending.